To explain how technology trends and the dynamics of buildings and data center are propelling a change, we have Shobhit Jain, Technical Manager from Commscope, who's going to talk about this. So Shobhit is responsible for all technical related activities in the North, East and Central India. He has a bachelor's degree in electronics and he has 13 years of experience in the structured cable industry. And he's been with Commscope for the last years, and earlier he has worked with system integrators, as he's going to talk a little bit about the technology trends of buildings and data centers. So please welcome on stage Shobhit Jain.
I have the privilege of being between you and lunch. Oh, there's a quiz, yes, but I mean, I'm the last speaker between the lunch and this session. So what I'm going to talk about is basically what are the industry trends and how these trends are going to impact the infrastructure. When I say infrastructure, I'm primarily talking about structured cabling and how these trends are impacting that. We'll talk about a little bit of the design considerations that one should have in order to cater to these changing trends. And then I'll talk about some of the emerging technologies in this area that will help in catering to the trends. So what are the three major challenges or the major trends that we see inside a building? Obviously, mobility, IP convergence, and Internet of Things. I'm not going to talk a lot about mobility because many people have probably talked about this in similar seminars like this. So I'm going to concentrate a little more on the IP convergence and the Internet of Things. What we see is that because of the IP convergence and Internet of Things, we see a lot of applications and a lot of services being deployed on twisted pair cablings, such as security, audiovisual, HVAC control, lighting, BMS. So what is the advantage of going on to a twisted pair cabling? Earlier, customers would have to chase after various vendors who would be taking care of the individual service. Instead, now, once it is transforming towards the twisted pair cabling, the customer only has to look after one vendor, and he himself can do the entire cabling for all these different services. Another big trend we are seeing in the industry is the IoT, and what we are actually witnessing is that 30% of annual increase in IoT connected devices are being witnessed. So for example, if you were to see, we've got almost 712 million IoT connected devices in the year 2015. But what we visualize is by the year 2021, we are visualizing 3,687 million IoT connected devices on the network. That's a huge explosion of connected devices everywhere. Whether we take any other vertical, could be health, hospitality, but another area is the manufacturing. Manufacturing is also coming up in a big way with IoT. So one of the things about IoT is that there are multiple technologies available in the industry, and the customers usually tend to pick and choose more than one of these technologies, and each technology has its own design considerations. Now, the customer will have to deploy a technology and also look at how this connectivity will happen. So what Commscope believes in, that there should be a generic methodology for the customers where all these different technologies can be accommodated. So obviously, the backhaul, whether it's a wireless technology or it's a wireline technology, remember one thing, that whether it is a wireless technology, it still has a wireline at the backhaul. So what are some of the talent challenges? Another big trend is the Wi-Fi. Now, I don't know any office out there that is not using Wi-Fi solutions. It started off really early in the year 2000 with the 802.11a and b, which was approximately 11 Mbps. It moved on to, and today we're using almost 802.11ac standards, which is wave 1 for 1 gigabits per second. This was fine because we were using category 5e or category 6 cables to cater meet these demands. But now what we're seeing is there are new standards coming up, and which was established last year in 2016, 802.11ac, Wave 2, which is giving you a throughput of 6.9 gigabits per second, or the 802.11ad, which is giving you almost 8 gigabits of speeds. So is our cabling, the existing cabling, good enough to handle these kind of speeds now? That's a very important question one has to look at. Obviously, if category 6 was only giving you 1 Gbps, then probably the present technologies, it will not be sufficient. You would have to probably move up towards category 6A cabling. But a problem that existing customers may have is that do I not have an option of moving towards these higher technologies with my existing infrastructure? Because everyone knows recabling in an office is a very big pain. So there is a little bit of respite or a little bit of help that the standards have given. And they say that it is possible to use the existing cabling in your office, whether it's Cat 5e or Cat 6, but they do not assure a performance on those. So if you look at this particular chart on the right-hand side, if you were to take, let's say, 2.5G base T, standard says that it could, you could achieve these applications on category 5 and category 6. Now, believe it or not, it has nothing to do with speeds. It is actually to do with the cable bundle size. That is the important thing. The more the number of cables in a bundle, the harder it becomes to achieve these different speeds. And if you see, as you go down the chart, you will see if you had a bundle length of 75 meters to 100 meters, probably Cat 6 and Cat 5e would not be able to give you the kind of performance you're looking at from the new standards and technologies. But what standards do say is that category 6A definitely will give you the required performance. Apart from that, the standards have a new parameter that they have introduced to check and do the testing whether the existing cabling will help you in achieving these kind of technologies. And it's called ALSNR, Alien Limited Signal to Noise Ratio. Basically gives you a mitigation process in case you were wanting to use a Cat 5e cabling system, existing Cat 5e cabling system, and you wanted to implement the 2.5G or 5G based technologies, and you were not able to achieve it, then it gives you a process of how you can mitigate that. For example, the first thing that they suggest is that you can change the patch cords on both sides from Cat 6 to category 6A, and then test the link again. In case it still does not happen, then you can change the information outlets to category 6A. Again test it, and if it still does not work, then you basically have no option, but you have to change the cable itself to category 6A. And that's where the standards say that it will definitely give you the required performance. So how do we design for Wi-Fi's in today's day? The traditional way of doing it is that a customer would ask one of the OEMs, the access point OEMs, to come and do a survey and generate a heat map. Now that's fine, but what usually tends to happen is once the site goes live, those heat maps really don't make sense, because it turns out where you were wanting to put an access point, the number of users were not that, and it changes. So what Commscope and the standards in fact have suggested that there is a methodology of doing it, and the standards for like in TIA, it's called TSB 162A. These are the cabling guidelines on how to Wi-Fi your cable, how to cable your Wi-Fi access points. So it's very simple actually. What they have done is they've taken the entire floor plate and they have divided it into cells of 60 feet by 60 feet. In each cell in the middle, they are proposing to have 2 outlets of category 6A. Now, with a patch cord of 13 meters as a maximum, they're able to reach to each corner of this particular cell. So that's one of the design methodologies that the standards have mentioned. You are aware that TIA is predominantly available in the US, so the Europeans obviously have to come out with their own set of standards, which usually does not have to be very different. So it's called the TR24704 standard. Instead of having a square shaped cell, what they've done is They have actually come out with a hexagonal shell. Wow, big difference, I know. So, and the other difference is that the length of the patch cord, they have limited it to 12 meters. Now, if you see in both standards, they have an overlap area with the adjacent cell. That is important because in case the density of users in a particular cell is high, then you may have to provision for more access points tomorrow. So that actually provides you that sort of a safeguard over there. Now, as I said in the beginning, there should be a methodology available for all, for the customers where they can implement it and not have to worry about the technology for IoT, Wi-Fi, whatever that they are about to implement. So Commscope has come out with its own methodology, and we call it the Universal Connectivity Grid. Basically, it's based on the standards only, and instead what we've done is, again, we have decided to create a grid on the ceiling, and we have decided to define the number of outlets that should be available for each service that the customer chooses to deploy. So for example, Wi-Fi, we have suggested for each access point, there should be 2 category 6A outlets. Whether we talk about in-building wireless, now in-building wireless, we're talking about distributed antenna systems, that is basically for your mobile connectivity, right? So we have suggested that there should be 2 outlets per wireless access, in-building wireless. Or if you could talk about sensors. Now sensors is a very big thing coming up, and the number of sensors in a grid of, let's say, a size of 60 feet by 60 feet is very, very high. So what we are suggesting is that there should be approximately 36 to 48 ports in each of these grids, because sensors are usually required, as my fellow colleague, fellow speaker was talking about, analytics. They can use a lot of that for analytics, occupancy sensors, what is this temperature, and all that kind of data can be generated. So what we are suggesting is almost 36 to 48 ports per the cell size. So as I said earlier, so a lot of these services are coming on to twisted pair cables. And what is interesting to understand and see is that the changes are not really happening on the floor. The changes are happening on the ceiling. So whether we're talking about access points, CCTV cameras, we're talking about sensors, lighting, access controls, and a host of other services, HVAC, fire alarms. So most of these applications and services are happening on the ceiling. So we should start thinking about a different methodology, the one I talked about, UCG, Universal Connectivity Grid, and start deploying that in our offices in case tomorrow we decide to move one of these services onto the twisted pair cabling.
So does it in the same way as the DLMS and the COSM are implemented for smart metering?
Yes, absolutely. Yes, something like that, absolutely. So another big trend is the adoption of PoE, Power over Ethernet. Traditionally, what have we using? We've been using PoE for powering our IP phones, powering on our CCTV cameras, or at most the access points. That was because the kind of power that was delivered through these cables was limited to 15 watts for PoE and 30 watts for PoE+. But the new standards, which are expected to be established in the year 2018, probably next year, we are talking about delivering 90 watts of power through these cables. And this is enough to power on your laptops, power on any network device that you wish to do. Already Cisco has come out with its proprietary PoE standard called UPoE, and they're delivering 60 watts of power to these end devices. Now one thing you have to start probably think about is, if I am increasing the amount of power that is being delivered through these cables, is there any impact of that on the cables itself? And the answer is yes, absolutely. Because as you increase the power in these cables, the heat that is generated in these cables will also increase. And as most of you would know, that as the heat increases, the performance of these cables will decrease. I don't know how many of you are aware, and there used to be a general perception out there that For network devices, there should be a maximum distance of 90 meters on copper. That's the general perception. Actually, that is not true. What standards say is that that is actually true for 20 degrees Celsius. When the ambient temperature is 20 degrees Celsius, the maximum distance should be 90. As it increases, the temperature increases, the distance actually decreases. That's a derating factor, called a derating factor. In India, most of the country, the ambient temperature is well above 25 degrees Celsius. I know most of us, no one follows it. But the fact is, it should be considered, right? So what are these standards suggesting? As you're increasing the amount of power that is being delivered on these cables, what should be done? So what they say, in case you've got the legacy category 5E, category 6 cables, then they have suggested that the cable bundles should be limited to 24 cables per bundle. And each bundle, the difference between each of the bundles should be approximately 15 millimeters. Now, that is fine for category 5E and category 6, and trying to implement that could be a very big challenge for customers. But if you were to use a category 6A cable, these problems or these considerations don't have to be used, because the category 6A cable has been constructed in such a way that the higher temperatures can be catered by these cables. So that's a very important thing. So of all the things I've discussed about, like PoE, Wi-Fi and all this, if you see, the general theme in this is that all these standards are saying that you should start evaluating category 6A for all your applications and all your services. And it has nothing to do with speeds, actually. Speeds, earlier, at least 4 or 5 years back, people used to say that, go for category 6A if you want to achieve 10 gigabits per second. But this is actually, that is one of the advantages, but it is not the only factor that you should evaluate. Most of these standards, like the education TIA 4966, healthcare TIA 1179, or all these other intelligent buildings, offices, Wi-Fi, PoE, data centers, they are all recommending that the customer should deploy category 6A for any new installations at least. Legacy, old installations, and you want to upgrade, obviously, they've given you the method of upgrading that. But in case you're going for a new installation, start evaluating category 6A, and not just because of the speeds. So, now I'm going to come to something about the data centers. And we are now all the, yes, please. It's not much. Honestly speaking, it would be around 35 to 40%. It depends on OEM to OEM, honestly speaking. But the difference is not very big, because as the volume of Cat 6A goes up, the prices are going to come down. It's economies of scale. It's very simple. 20 years back, or let's say 15 years back, Cat 6 was a very expensive solution. And people did not want to change from Cat 5e to Cat 6. But as the volume started increasing, the prices started decreasing. So it's the same story here as well. So coming to the data centers, the traditional architecture used in data centers earlier was a 3-tier architecture, right? You had the cores, the aggregation, and the access switches. Now what is happening is things are shifting towards a spine and leaf architecture, right? That's what everyone's been talking about. And for a layman, what does spine and leaf architecture mean? It means that all your leaf switches are connected to all your spine switches. So when that starts happening, you need a larger pipe, you need a higher performing cabling system in place. Another big thing is some disruptive technologies have come into the market, such as software-defined networks, where they are talking about bare metal switches, white box servers, where the customer configures all these devices on their own, and they do not have to rely on a specific OEM. So these kind of things are coming up in this industry. Traditionally, customers talked about migrating from 1 to 10 to 40 to 100 gigabits per second. Now they are actually evaluating different speeds, like 25G, 50G, or even 200 or 400G. So these are the different types of speeds that are being talked about now. parallel multi-mode was the way to go in data centers earlier. But now, as things are changing, single mode is actually becoming very prominent in hyperscale data centers. When I say hyperscale data centers, we're talking about data centers which are like thousands and thousands of racks. So obviously, the size of these data centers are huge. And then we have different elements like hyperconvergence. So all these disruptive technologies are taking place. So your solution that you want to deploy inside a data center should be able to cater to all these changes that are happening inside data centers and still be able to support legacy applications. That's very important. So what does the Ethernet roadmap talk about? The Ethernet Alliance, they had, if you remember, in 2010, the speeds of 10 gigabits per second, 40 gigabits per second, and 100 gigabits per second were defined. So it was pretty straightforward for customers that they would have to migrate from 1 to 10 to 40 to 100. And since, but lately, like in the last year, 2016, 25 gigabits per second came up. Reason being, customers felt that I really don't need to jump from 10 to 40 immediately. I want a speed which should be there in between, because it's really overkill for me. So they started, this particular standard came out for 25 gigabits per second, and probably by next year, they're going to come out with the 50 gigabits per second. So anyone who wants to jump from 40 do not have to go straight to 100, they can probably start talking about and looking at 50 gigabits per second as well. The problem in all this is, the 10 gigabits per second was working on duplex fibers. When I say duplex fibers, one fiber for transmission, one fiber for receiving. But as soon as you move from 10 to 40, you start talking about parallel optics. A 40 Gbps on parallel optics means that you need 8 fiber cores, 4 for transmission and 4 for receiving. But with the with the new technologies coming up like SWDM, shortwave division multiplexing, you can actually fall back on duplex connectors. Like Cisco's BiD transceiver module, they only use 2 fibers, right? And they still are able to achieve 40 Gbps of speeds. So now the customer starts having a lot of confusion. Do I continue with the parallel optics or do I stick to duplex? So this is a very big problem that we are seeing in the customer space, where they are not really sure which kind of an architecture and what kind of a solution should be deployed in their data centers. So actually, we call this the transition zone. All these different types of speeds can have a duplex transmission, or they could have a parallel transmission as well. So this is one of the big problems. So now the solution that you should look at should have 3 main features. It should be crowd friendly. When I say crowd friendly, it means that it should be a plug and play solution, and it should be able to adapt to tomorrow's application as well as today's applications. You should be high density, because as the data centers increase, as the number of connects increase with the leaf and spine architecture, you should have higher density, and least amount of space being utilized inside your data centers. And it should be agile and flexible. That means that you should be able to switch from duplex connections to parallel optics and vice versa at will. So we've come out with a new solution called SystemAx Ultra Low Loss Solution. And why? For high speed migration. And why? Because the application speeds are increasing, pretty straightforward, right? But the optical loss budgets are decreasing. Now that's a very important thing. When you're trying to achieve a 10 gigabits per second channel, the optical losses are pretty much safe, around 4 to 5 dB. But as soon as you go towards 40 gigabits per second, that drops to almost 2 dBs losses. So the solution that should be there should have a very low loss, so that you are able to go from 10 to 40 to 50 to 100 to 200, whatever speeds that you're wanting. 100 meters. So that's a huge reduction on the channel length. And more media options. What I mean by more media options is, you've got tons of transceiver modules out there which you can choose from, whether it's single mode or multi-mode. So that's becoming a very big problem for customers, how to go about that. So with this solution, you are able to support high speed migration. When I say that, you can easily go to any speed that you wish to do, or allow for additional connectors. Now, as you increase the number of connectors in a channel, the losses will increase. So you've already got a small, power budget or a loss budget, and you're trying to reduce it even further by introducing further connections. So this solution will allow you to actually add more connections without having to compromise on the power budget.
So can it use RS-248?
RS-248, yes, absolutely. I think I'll have to check on that, but let me see whether you can use RS-248. Okay, and it simplifies media selection. It's very easy. Right now, you've got a solution in place which can easily migrate from 10 to 100 to 400, and you do not have to worry about, because the channel lengths are still quite substantially large, so your media selection becomes a lot easier. Enabling complex topologies. Now, in a large data center, you would have to go through various areas in a data center to finally reach the end device that you're wanting to connect. So as you do that, number of connections increases, the length increases, the topologies become very complex. So this solution will allow you to actually, help you in trying to solve all those problems. Does this give you a small glimpse of one of the products? So and we were talking about high densities. So this particular panel that we've come out with for this particular portfolio, it gives you two variants, high density and ultra high density. High density talks about 48 duplex LC ports, and the ultra high density talks about 72 duplex LC ports. That's 144 fibers in a single RU, in a single U panel. And the best part is it supports single mode, it supports OM4, and it also supports OM5. And I will be talking a little about OM5 because it's a new thing that has come up. And the best part is it supports intelligence. So I don't know how many of you are aware, but there is an entire different solution out there that allows your whole passive infrastructure to become automated. So I'll talk about that as well in my subsequent slides. So the solution portfolio that we've launched recently has a 24 fiber MPO, and that is what we are recommending to our customers because it has the lowest cost duplex and it supports the highest density. But we also have the entire portfolio range for the MPO 12 because that is what has been deployed largely by the customers in the industry. And we also support, MPO 8, especially for the QSFPs. That's where when the customer wants to connect one active device to the other active device directly. So we do support all these three, and we've got the entire range. Now, wideband multimode fiber, OM5. I said I was going to talk to you a little bit about that. What is that? Basically, in the year 2015, we had already witnessed and understood that these are the trends that are happening in the data centers. So what we decided to do is we decided to develop a new type of fiber and we called it wideband multimode fiber. And what this fiber basically does is it allows multiple wavelengths to be transmitted on a single fiber strand. Now this technology is not very new for telecom users because they've been doing that for ages. They've been doing that via WDM, wave division multiplexing, on single mode fiber for donkey's years. But that same technology was till now not available on the multimode fiber. And that's where we started working on it. We started to develop a new fiber altogether for that. What it helps in doing is, it actually helps you in reducing the number of fiber counts. That's a very big, and it still supports your legacy applications. So, in the year 2016, October, they decided to call that OM5. In fact, the standards, then they said, okay, this is actually something that will be beneficial to everyone. So they wanted to use that into the standards and say that, okay, instead of having just OM1, OM2, OM3, and OM4, they said, let's have OM5 as well. And actually, it was developed by Commscope only. So, and the way to identify that is very easy. It's got a lime green color, apart from the aqua color, which is there for OM3 and OM4. So if you see this particular chart, it gives you a pretty clear idea of how it is able to help you. A 40 gigabits per second, it traditionally would have required 8 different fiber strands. On SWDM, short wave division multiplexing, you could achieve the same 40G on 2 fiber cores. Similarly, 100G would require 20 fiber cores, 10 for transmission, 10 for receiving. And you would still achieve that same speeds on 2 fiber cores. Now, this is actually a boon for the customers. That's where then they start saying, oh, finally, we don't have to keep on increasing the number of fiber cores in our data centers. We can now think about reducing them instead of increasing them. So, as I said, they've already been established as a standard by the ISO IEC 11801-1. So they've already got those standards in place. I'll just give you a small idea of how OM5 it can really help you in the distances. So OM5 is able to achieve 200 meters instead of 150 meters on OM4, right? SWDM can achieve 440 meters instead of 350 meters. That's a huge increase in the lengths and the channel lengths. One of the biggest key points in the portfolio is that you are able to get method B enhanced. That is the polarity problem with fiber cabling. Polarity is a big problem with fiber. So you're able to achieve all that with the method B enhanced and not have to worry about polarity anymore. I've already talked about the panel, ultra low loss and all these. Application assurance. Now that's basically what we do. We've got a tool, online tool, that you can download for free and check whether the channel that you have configured will be supported by a particular application or not. You can do that on your own, but as a caution, this is only applicable for SystemX solutions. Do not try to use this tool on other OEMs. They will not work over there. Okay? So some containment areas that we have, fiber guide system. Basically, this is a system that is primarily meant to be made for the fiber cabling inside data centers. And what it does is, it ensures a 2-inch minimum bend radius in the entire system. So you do not have to worry about bend radiuses when you are trying to deploy this solution. Similarly, we've got a solution for copper cabling as well, with all the, it's a plug-and-play solution, modular, it goes without any nuts and bolts, so it's very easy to deploy. Almost the last thing I want to talk to you about is how well do you know your cabling infrastructure? Now, this is an important thing. You are all aware about your networking layer and above. You know what switches are being deployed, you're all aware about how the things are happening. But you have no clue about how your passive infrastructure is. How many ports are available? How are they connected? And honestly speaking, this is what I see. When I see a customer asking that, he just closes his ears and he closes his eyes. He says, I don't want to get into that. So this solution will help you in dealing with all that. It will give you documentation, up-to-date documentation. You do not have to worry about what are the changes you've done in the entire passive structured cabling. It will manage it, it will optimize it, it will tell you what are the panels, ports available, what speeds these particular ports are working on, whether it's a PoE port or not. All this information will be given to you through this solution. And because in the interest of time, I am going to really go fast. It's a standard. In fact, Commscope, again, we decided to push for a standard dedicated for automated infrastructure management, because earlier this was only given as a reference in some of the earlier standards. Now, in last year, we decided to push for it, and we got a standard dedicatedly for this particular solution. And for the interest of some people, it will allow you to do a host of things which you were never able to do earlier.
It's an open source.
It's an open source, absolutely open source. So it can be integrated with any other third-party software if you wish to do that. So it's very easy. It's got 3 components, and it's got a software based. So the software is loaded onto a small server, and you can actually monitor the entire passive structured cabling in real time. So last couple of slides. There's a new solution that we have launched also called Powered Fiber Cabling System. And this is basically used for the network devices which are going outdoors and which are going beyond 90 meters. The problem with that with customers is once it goes beyond 90 meters, they have to resort to fiber. And once they're on fiber, they really can't use a PoE, right? They can't transmit and deliver power over the fiber. So they have to create a different power infrastructure as well as a communication infrastructure. So what we've done is we've combined both the things into a single solution, and now the customers do not have to worry about creating separate infrastructures, and it can be managed very easily through, and the distances that it can achieve is quite staggering. On 15 watts, it can go up to 3 kilometers, and on 30 watts it can go up to 1.6 kilometers. That is an ideal solution where you've got large campuses, large plants, and they have to have CCTV cameras across the periphery and all those kind of things. It's very simple. It's got basically a cable, it's got a PoE extender, and it's an IP68 rated device. So you don't have to worry about temperatures, you don't have to worry about water, everything. It's self-sufficient. So with that, just wanted to say that, yeah, we're basically everywhere. So Commscope, whether you want to see us in data centers, we're there. Whether you want to see us in wireline networks, we're there. Wireless networks also there, and in buildings and large venues. That's it. Thank you. So any questions that people might have? Yeah.
Now that we are, transferring energy with data,
Yeah.
and we have seen that mobile networks and radiations cause a lot of hazards.
Mm-hmm.
So do you think that those will impact our biological body?
Actually, Commscope has an entire in-building wireless solution also. It's called distributed antenna system. What we're doing is, you're right, when you've got a tower somewhere, you've got this huge amount of energy which is being transmitted to your handheld device. Now the problem is, if the signals are low, your power of the mobile phone actually increases. So, and you put it all the time right next to your head. So what we've done is we've distributed that signal and distributed it across the entire floor or building. And it is all very low powered. So what it helps is, it helps you in saving your battery as well, and the quality is digital. So we've got this entire solution, and we've got an entire team sitting out of Gurgaon, it's very nearby, who does deal with all in-building wireless based solutions.